Oh, hi again. Thank you for showing up for your learning. Now we're looking at a quadratic formula where we get to rational solutions or irrationals. There are times where we're going to have to simplify some of our radicals here, so there is a new dimension to this practice. If we're looking at this situation where we have 6k squared plus 6k minus 6 equals k, and we want to solve for k. Okay, we recognize that this is a quadratic equation in k because it has a k squared, and we just need to simplify, then apply the quadratic formula. I've been saying a lot, if you can do mental math, then it's going to be more fun and it's good practice. If you can do quadratic formula mental math, that's fantastic. Now, let's take a look at how we do these. You could start by copying out the whole thing. 6k squared plus 6k minus 6 equals k, and then subtract k from both sides because we need an equation equals 0 in order to use the quadratic formula. 6k squared plus 5k minus 6. Now we can't factor out the 6 anymore. Too bad. We just have to use quadratic formula here. No way to simplify. So we copy out the quadratic formula with a little jingle. Negative b plus or minus the square root of b squared minus 4ac over 2a. Never get the 2a part in time for the jingle. Okay, and then you just substitute in. B is 5, so we have negative 5 plus or minus the square root of 5 squared minus 4 times negative 6 times 6. 4 times 6 times negative 6. Okay, all divided by 2 times a, which would be 12. I skipped a step. It's 2 times 6, okay? It's 2 times that number there. I move pretty fast, I know. No, it's not a big deal. Okay, so now 5 squared minus 4 times 6 times negative 6. Let's do the discriminant first, because that's where we can simplify. 5 squared is 25. Negative 4 times negative 6 is positive 24. 24 times 6 is, 144. Yeah. So that's 25 plus 144. I happen to know it's going to be 169 because it's a Pythagorean triple. Cool. I see how they built this problem. All right, minus 5 plus or minus the square root of 169. Check your calculator if you don't like my mental math, okay? And you'll find that it's true. Okay, square root of 169 is 13. So this is equal to negative 5 plus or minus 13 over 12. That's going to lead to two solutions. Negative 5 minus 13 would be minus 18 over 12. So this is k equals. We should also highlight this. This whole thing, the whole point of the quadratic formula is it tells you what k equals. If you have a quadratic of the form ax squared plus bx plus c, a quadratic in standard form, that's equal to 0, then the quadratic formula tells you what the variable is equal to. And it will give you two solutions, one solution, or no solutions. In this case, 2. All right, so k is equal to negative 18 over 12, or it's equal to negative 5 plus 13. Someone loves Fibonacci here. Plus 8 over 12. Yeah. Okay, so now reduce your fractions. Negative 18 over 12 is equal to negative 3 over 2, or 8 over 12 is equal to 2 over 3. Okay, love Fibonacci, these guys. Minus 3 over 2, comma, 2 over 3. So mid-answer. Yep. Yeah, k is equal to those points. Cool. Cool. Okay, so that's how you do those. That's pretty straightforward. But it's these ones that are a little bit more interesting because they're not going to give you nice perfect squares inside the discriminant, inside that square root sign. You're gonna need to apply your new radical skills to these ones. So here we have n squared plus 2n minus 11 equals 0. Okay, so because it's equal to 0, we can apply the quadratic formula, and there's no simplification that needs to be done here. We just do n equals, you guessed it, negative b plus or minus the square root of b squared minus 4ac over 2a. Almost got it. All right, and then we have negative 2 plus or minus the square root of 2 squared minus 4 times a. A is 1, so minus 4 times c, which is negative 11, all over 2, because a is 1, so I'm just going to write 2, okay, equals negative 2 plus or minus 4 squared plus 44. This is root 48. Oh man, that's got some perfect squares in it. 48 is divisible by 16. Yes, it's divisible by 16. So it's 16 times 3, right? Yes. Okay, it's 16 times 3. That's been a long day, okay? 16 times 3. All right, all over 2. Okay, I just simplified the discriminant there. It's 48. And now let's keep going. Negative 2 plus or minus the square root of 16 times 3 all over 2. Okay, 16 is a perfect square. It pops out in front. So this is going to be equal to negative 2 plus or minus 2 root 3. Oh, geez, I did it again. Writing down the final answer and skipping steps without skipping the step. You know what I mean? You don't, but anyway, I do. Okay, all divided by 2. And then I knew that this 4 is going to be divided by 2, and this minus 2 is going to be divided by 2. So this is equal to minus 1 plus or minus 2 root 3. And that's the final answer. Negative 1 plus or minus 2 root 3. If you can do these in your head, woo, fantastic. I'll get you some bonus points if you can do these in your head. These are cool. If you can like work through and give me an answer like that in your head, wow, that's really great. So practice lots of these and try doing them in your head. See if you can do them. Okay, so that is just apply your radical skills. All right, the discriminant here, 2 squared minus 4 times minus 11 gave 48, the square root of 48. 48 is 16 times 3, so I recognize a perfect square there of 4, which pops outside the radical and then simplifies with this fraction. So to do these, you have to use fractions, all right? It's not like fractions are a choice in math class. You want to go to a high level in math, you got to get good at fractions, okay? So get over your dislike of fractions if you're still, I don't like them. just try and change that language. Like, I don't like them yet, but I see that they're very important. So I'm trying to get along with fractions. That would be an improvement. And if you have any questions, hit me up by email. Otherwise, come find me on Tuesday. Bye for now, everyone.